For part C, we want to take things to the next level, and we want to show how we can solve any triangle, not just a right triangle. And we're going to use two methods for this. We'll use the law of sines and the law of cosines. And what we want to do is be able to just identify, based on the information given, which one of these two, the law of sines or the law of cosines, will actually help us solve the triangle. So remember, the law of sines states that A over sine of A equals B over sine of B equals C over sine of C. And again, the beauty of this is that it works with any triangle, not just right triangles. So if we're given a triangle and some information, we want to substitute the values that were given and see if we have any complete ratios. If we have complete ratios, then we will be able to set up a proportion and solve for our unknown values. If the law of sines does not work, we can often use the law of cosines, which is a squared equals b squared plus c squared minus 2 times b times c times the cosine of a. Now, this can be rewritten to solve for any side, whether it be a, b, or c, or any angle, whether it be angle a, b, or c. And we just need to make sure that, if you'll notice on here, the outsides, a squared and cosine of a. If we're solving for b, then it would be b squared equals and the cosine of b. Again, with the law of cosines, we can solve any triangle. The law of cosines is helpful when we have side, 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 or side, angle, side. The law of sines should work for most, if not all, of the others. So let's look at number 1. Our first step is to substitute the given information. But before we substitute, we want to label our triangle so that we don't get mixed up the sides that we're talking about. We have angles A, B, and C, and opposite each angle is lowercase for the side. Side A, side B, and side C. Now when we substitute here, we see that if we look at the ratios for angle B and side B and angle A and side A or C, we'll see that we have 3 out of the 4 pieces of information that we need, and we're asked to solve for the length of side B. Since we have 3 out of the 4, we know that we can use law of sines. So this first one is solved by using the law of sines. The second one, let's substitute our information that we're given. We see that we have one piece of information given from each of the ratios. That does not allow us to solve. So we need to look at the law of cosines. But wait, remember the triangle sum theorem. The interior angles of a triangle add up to 180 degrees. Since we were given 2 angles, we can easily calculate the third. And once we have the third angle measure, we see that the law of sines will work. So the law of sines works for number 2 as well. We're given 2 angles and any side. Number 3. Again, we start with looking at the law of sines and we substitute our values. Here we see that we've got 2 sides and 1 angle. 1 piece from each ratio. This does not give us enough information to use the law of sines. And in this instance, we only have a single angle, so we can't determine any of the others at this point. So we look at the law of cosines. It's written as a squared equals b squared plus c squared minus 2bc cosine a. But we're solving for c, so we need to rewrite our equation as follows. After we substitute, we have the following. C squared equals 11 squared plus 8 squared minus 2 times 11 times 8 times the cosine of 16. So we have everything we need to successfully solve for C. So here we can use the law of cosines. Number 4, right away when we look at this, we see that we're not given any angle measures. We just have all 3 sides. So we don't have enough information to complete any ratio or to solve for any proportions. So the law of sines will not work. We look at the law of cosines. Here we're solving for angle A instead of for the side. So we need to rearrange our formula so that we isolate the angle variable. And to do this, we need to be very careful that we're using the properties of equality as we subtract b squared and c squared, and then we divide by -2 times b times c, and then finally take the inverse of the cosine. So we're solving for angle A. Now, one note of caution: be careful when you plug these values in that you use parentheses and follow the correct order of operations so we get the right answer. But number 4 is handled solving for x using the law of cosines. Number 5, again, we'll substitute what we have, and when we substitute, we see that yes, law of sines will work because we have 3 out of the 4 pieces of information. We have a proportion that we're able to solve. For number 6, if we substitute, we see that we have 1 angle and 1 piece of information from each ratio. So we can look at the law of cosines. Since we're solving for b, again, we rewrite the equation as follows. And after substituting, we see that we can solve for side b using the law of cosines.